Hello guys, hope you're doing well. I am Said and welcome back. In this video, we're solving definite integrals of floor functions, also known as the greatest integer function. Since these are piecewise constant, we'll learn how to break the interval at each integer step. Let's get started. Number 1, the integral of the greatest integer x dx from 0 to 5. We split into intervals where the greatest integer is constant. So we have 0 to 1, 1 to 2, 2 to 3, 3 to 4, and 4 to 5. So we have the integral of from 0 to 1. As you know, on the interval from 0 to 1, the floor of x is 0. So we have 0 dx plus the integral of from 1 to 2. And as you know, on the interval from 1 to 2, the floor of x is 1 dx plus the integral of 2 to 3 from 2 to 3. As you know, on the interval from 2 to 3, the floor of x is 2 dx. The integral of from 3 to 4. On the interval from 3 to 4, the floor of x is 3 dx plus the integral of from 4 to 5. On the interval from 4 to 5, the floor of x equals 4 dx, right? So the integral of 0 dx is 0 plus the integral of 1 dx is x from 1 to 2 plus the integral of 2 dx is 2x from 2 to 3 plus the integral of 3 dx is 3x from 3 to 4, and the integral of 4 dx is 4x from 4 to 5, right? So we have x from 1 to 2 is 2 minus 1 is 1 plus 2 times 3 minus 2 is 1 plus 3 times 4 minus 3 is 1 plus 4 times 5 minus 4 is 1. So 1 plus 2 plus 3 plus 4 is 10. Number 2, the integral of the floor of x dx from 1 to 4. We split into intervals where the floor of x is constant. So we have 1 to 2, 2 to 3, 3 to 4, right? So we have the integral of from 1 to 2. On the interval from 1 to 2, the floor of x is 1 dx plus the integral of, on the interval from 2 to 3, the floor of x is 2 dx plus the integral of from 2 to 3, from 3 to 4, the floor of x is 3 dx, right? So we have the integral of 1 dx is x from 1 to 2, 2 dx is 2x from 2 to 3, and this integral becomes 3x from 3 to 4. So we have x from 1 to 2 is 1 plus 2 times 3 minus 2 is 1, plus 3 times 4 minus 3 is 3 equals 6. Evaluate the integral of the floor of x squared dx from 0 to 3. Again, the floor of x is constant on each unit interval on 0 to 1. The floor of x, for example, if x equals 0.5, the floor of 0.5 is 0, right? And on 1 to 2, the floor of x equals 1. And on 2 to 3, the floor of x equals 2, right? So the integral becomes the integral of from 0 to 3, the floor of x squared dx equals the integral becomes 1 to 2, 1. Sorry, 0 to 1, 0 to 1. The floor of x squared dx plus the integral from 1 to 2, the floor of x squared dx plus the integral from 2 to 3, the floor of x squared dx, right? So the final answer is on the interval from 0 to 1, the floor of x is 0, right? So 0 squared is 0, plus on the interval from 1 to 2, the floor of x is 1. So the integral 1 squared dx from 1 to 2 plus on the interval from 2 to 3, the floor of x is 2. So the integral of 2 squared dx from 2 to 3. So we have 1 squared is 1. So the integral of 1 dx is x from 1 to 2 plus the integral of 4 dx is 4 x from 2 to 3. So the answer is 2 minus 1 is 1 plus 4 times 3 minus 2 is 1. So we have 5.